Further continue. Now let's see DTC handling in electric and hybrid vehicles. So DTC handling in IC engines is a different ball game, and DTC handling in electrical and hybrid vehicles is a totally different ball game. We will have a brief look at it. Now diagnostic trouble code handling in electric and hybrid vehicles differ significantly from traditional internal combustion engine vehicles due to their unique architecture and systems. Okay, why is it different ball game? As I said, because these vehicles, EVs and hybrids, they have a totally different architecture and system. And let's break it down. Key differences in DTC handling handling for EV vehicles. EVs rely entirely on electric propulsion, which introduced specialized components and fault detection needs. And when it comes to, well, this is more or less common. These have a totally different powertrain. Okay, so naturally specialized components and fault detection is needed. And when it comes to EV specific systems monitored by DTCs, monitors voltage, temperature, and cell balance. Okay, so the purpose of BMS is to monitor voltage, temperature, and cell balance, and electric motor and inverter. Tracks torque delivery, thermal status, and phase currents. And when it comes to charging system, the same diagnostics, they detect the faults in onboard chargers and electric interfaces. Again, when it comes to high voltage safety, insulation faults, contactor failures, and leakage detections. Okay, so all these are the various systems or the various different aspects of the EV that need to be monitored by the onboard diagnostics. And common EV DTCs, well, the DTC nomenclature more or less follows the same procedure as the IC engine DTC. I'll give you some examples. P0 P P0A80 means battery pack deterioration. PE P1E100 general hybrid electric system failure, and P0A6 high voltage battery insulation fault, and U0293 lost communication with battery module. These codes often require specialized diagnostic tools and high voltage safety protocols. This is important because you are working in an environment where high voltage is prevalent. Okay, so in an environment where high voltage is prevalent, specific high voltage safety protocols must be followed during the servicing. Now, DTC handling in hybrid vehicles. Hybrids combine ICE and electric systems, so their diagnostics must cover both domains. Now, dual powertrain monitoring, engine plus electric motor coordination. Next is next important challenge is regenerative braking, and you DTC sometimes fast to find fault or identify fault in energy recovery systems. And when it comes to mode switching, errors due to transition between electric and IC modes, and this is very prevalent in hybrid vehicles, especially during city traffic where very frequently, very often, the mode of transport keeps shifting between electric and ICE modes. And when it comes to battery and cooling systems, similar to EVs, but with added complexity due to ice heat. Okay. Now, when it comes to typical hybrid DTCs, here is the list. POA7F hybrid battery pack malfunction. PIC10000 means motor cooling system fault. P3000, it is battery energy system storage. And when it comes to P0A92 hybrid inverter malfunction, so these are the various kinds of DTCs that are prevalent in hybrid vehicles. Now, when it comes to diagnostic tools and techniques, both EVs and hybrids need advanced diagnostic platforms. OBD2 scanners. All right. So the first important tool is a OBD2 scanner to find the basic fault reading limited to EV and hybrid specific codes. Next is OEM software, deep access to proprietary systems. So this OEM software is usually a proprietary system. So a diagnostic tool should be able to monitor the OEM software. And when it comes to battery analyzers, evaluate cell health and voltage balance. Next is multimeter and installation. I gave a very elaborate discourse about the specialized tools. So in that tool, you can find the working of multimeter and installation testers. So when it comes to safety and maintenance consideration, high voltage systems require insulating grounds, Cat 3, 4 multimeters and strict protocols. And clearing the DTCs without resolving root causes can disable propulsion or charging. This is very important. Okay, I emphasized this in the previous video and now also I'm emphasizing. In case you are a onboard diagnostic professional, never ever 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 clear a DTC unless and until you resolve the root cause. Now some faults like POAOA may prevent vehicle startup until resolved. Okay, so it is not exactly foolproof that all the DTCs must be cleared before restarting the vehicle. But having said that, there are some specific DTCs which are very pivotal, which make sure the vehicle will not start unless and until you restart the, unless you clean up the DTCs. All right, thank you.